Okay, starting out today, lecture 31, excuse me. We're going to simplifying logarithms and looking at exponential models. Now, there are three things that basically we're going to cover today. One, we're going to simplify and solve equations using logarithms and exponential functions, and they're going to be a little bit more difficult than last time. Two, we're going to have logarithms, exponential functions with two variables, and they're going to look really complex and crazy. And then our third one is we're going to be dealing with some word problems that involve exponential functions. So, it could get a little hairy today, but we're going to go through this whole lesson, and then next time we're going to have a review day over this stuff. Okay? So, let's go ahead and get started. First off, solving just more complex equations. I've got negative 2 log base 4 of x equals log base 4 of 9. Okay, now the first thing I notice when I'm looking at this here is I'm noticing that both of these here have the same base. So that's a good thing, right? We would like those to both have the same base. There's a couple different ways we could solve it. One way is we could move this log base 4 over to this side, and then we can use those rules that we learned our first lesson in lecture 30, which would say that I can combine those two logs together. Okay, so for example, I can subtract log base 4 of 9, subtract, actually, you know what? That's not very smart. Let's switch it. Let's do this the other way, just so I can get rid of this negative. That's the only reason I'm thinking that. Add log base 4 of x, add 2 log base 4 of x. That'll work better just because then we won't have to deal with negatives. Now, there's nothing over on this side, so I've got 0 equals log base 4 of 9 plus 2 log base 4 of x. Okay? Now, first thing I'm seeing, I've got this 2 out in front. I need to move that 2 up into the exponent, right? Okay? So if I do that, I end up with 0 equals log base 4 of 9 times x squared. I combine those together. There's an addition sign there. An addition sign means that I can combine them together with multiplication. Okay? Remember, it's x squared here because we moved that 2 up to the x. Okay? So now I've got 0 equals log base 4 of 9x squared. So if I want to get rid of that log base 4, I can exponentiate, which means I've got 4 to the 0 power equals 4 to the log base 4 of 9x squared. Okay. We did that so that these would cancel. We're getting rid of our logarithm. I've got 4 to the 0 power. That gives me 1. And that equals 9x squared. Okay, so I've got 1 equals 9x squared. From here, it's fairly simple to solve. Divide by 9. I get 1/9 equals x squared. I've got to square root both sides. Okay, square root both sides. I end up with x equals plus or minus 1/3. So, fairly complex. Big thing on this, as far as from the beginning, that tells us that we can even solve it. I've got a log base 4, same base. I've got a log base 4, same base. Other option that you could have done from the beginning, if you wanted to, you could have moved your 2 up here at the start, okay? And then you would have had to exponentiate using your 4s, and that would have gotten rid of your log base 4. But I honestly think this first way that we did it is a little bit easier. So that's our first more complicated problem we've got to solve. Okay, second, I've got 2 log base 3 of x plus 4 minus log base 3 of 9. Okay, again, logarithms both have the same bases. Okay, that's a good start. Again, we want to try and combine these logarithms, but before we do that, we've got that 2 in front. We're going to need to move that 2 up top. Okay? So when I do that, I've now got a log base 3 of x plus 4 squared minus a log base 3 of 9 equals 2. So I can go ahead and combine those. I've got a minus sign there, so that means this is going to be combined using division. So I've got log base 3 of x plus 4 squared over 9 equals 2. Okay, so I had a minus sign, so I combined using division. It's x plus 4 squared because I had to move the 2 that was out in front up to the top. All right, now I'm going to be ready to exponentiate to get rid of that logarithm. So 3 to the log base 3 of x plus 4 squared over 9, whole lot of stuff up there, equals 3, whoops, yep, that's right color, squared. Okay, so 3 to the log base 3, that's good because those are going to cancel for us. And that means that I am left with x plus 4 squared over 9 equals 9. Okay, we've got just a basic equation now. We've gotten rid of all the logarithms and exponential stuff. Okay, I got this 9 on the bottom. Let's go ahead and get rid of that 9. Okay, multiply both sides by 9 to get rid of that. Multiply this side by 9 here. That gives me an x plus 4 squared equals 81. Now, we could multiply out that x plus 4 squared, but if I look over to this side here, that 81 is a perfect square number. So I can just square root both sides, and that works out pretty nice. It's going to give me an x plus 4 equals plus or minus 9. And then to solve that to get my two answers, I'm going to have an x plus 4 equals 9 and an x plus 4 equals negative 9. And I find that x equals 5 and x equals negative 14. Okay? So, longer problems, same basic principles. The only thing that's really new with these is that if you have two logarithms, you need to make sure with those two logarithms that you try and combine them. Okay? If the logarithms don't have the same bases, you're probably not going to be able to solve it. So these equations are going to have to be able to set up for you to be able to combine the logarithms. Okay, now we've got exponential functions here. I've got 5 to the x squared plus 5, or sorry, I said that wrong. 5 to the x squared equals 5 to the x minus 12. Again, same basis. That's good. If we've got stuff up in the exponent that we need to get down, okay, we need to hit it with a log. So I'm going to hit this with a log base 5 of 5x squared. And I'm going to hit it with a log base 5 because we have to do the same to both sides of 5 to the x minus 12. Okay? Your log base 5 and 5 cancel. Your log base 5 and 5 cancel. So I'm left with x squared equals x minus 12. Okay? I see an x squared and an x in an equation. The only way I'm going to solve an equation like that is going to be by factoring. So I need to get this set equal to 0. I'm going to move my x over and my 12 over. Gives me x squared minus x plus 12 equals 0. Okay, now I'm ready to factor. You guys can go through your steps. This thing, though, will factor to an x minus 4 times an x plus 3 equals 0. And I get x equals 4 and x equals negative 3. Okay. Again, bases are probably going to match. Actually, in this one, you can kind of make a few adjustments, but it's especially on your homework, they're going to have the same bases when you guys are working through these on your homework. Okay. So we're good on that first part. All right. Now we've got e's for our bases. Remember, we need to be thinking, what's the inverse of our e? Well, that would be our natural log. Okay, so I've got stuff up in the exponents, and I need to get that stuff down. I'm going to need to hit it with a log, and since it's an e, I need to hit it with a natural log. So I'm going to have ln of e to the 2x minus 7 equals ln of e to the 5 minus x. Okay, my ln and e's cancel. So all that I'm left with is a 2x minus 7 equals a 5 minus x. Now this one we don't need to worry about factoring. I just have x's up there. You only have to factor if there's an x squared and an x. Okay, so for this, I'm just going to add x and add x. And I'm going to add 7 and add 7. So that takes away the x's over there. It takes away the 7's here. And I get 3x equals 12, which gives me x equals 4. Okay? So they still end up being basic equations. Logarithms, remember, if they have the same bases, you can combine them together. Addition is multiplication. Subtraction is division. Okay? As far as dealing with your exponential functions, you're going to need to hit it with a log, and it needs to be with the base. So for these here, we were solving with e. We had to hit it with a natural log. So hit it with a log with the proper base so that it will cancel.